Good day to everyone. I'm June, and today I will be presenting my dissertation project titled Face Processing in a Multiracial Environment, Differential Experience in Face Recognition, Face Categorization, and Kinship Detection. I will first give a brief introduction and review of the area, followed by experiments and results that was done, and conclusion for the dissertation project. One key question that researchers have asked is, how do we recognize and remember faces? How does the system emerges? Are infants born with an innate system ready to process faces? How much experience is modulating it? Past studies from newborns and infants' preference of recognition of schematic faces and imitation of facial gestures have suggested that humans may be born with specific mechanisms to recognize faces. While the role of nature have been strongly suggested with these evidences, other studies have also suggested that we continue to learn information about faces from our environment. For example, infants after a few hours to days of exposure to their caregiver's face rapidly learn to distinguish their caregiver's face from other strangers' face. When we view a face, two automatic processes are triggered: categorization of whether the face belongs to our own group or species, and recognition of the face at an individual level. Recognition of a face have also been found to be disrupted with the other race effect. The other race effect is the well-established phenomena that individuals discriminate more easily between faces of their own race than between faces of other race. This effect has been demonstrated with different research paradigms and different countries and racial groups. Several theories have been proposed to explain the other race effect. Three major classes of theories that have received the most support are perceptual learning models, social cognitive theories, and categorization individual models. One of the most supported and researched explanation of the ORE account can be generally categorized as the perceptual learning models. Different theories fall under this model with the core explanation that different experience leads people to encode same and other race faces differently. In the contact hypothesis, it postulates that the ability to recognize the other race faces is influenced by the degree of contact with them. Greater degree of contact leads to higher experience with own race faces, resulting in superior encoding and recognition of these faces. Similarly, it is the lesser interracial contact that leads to poorer encoding and memory of other race faces. In the multi-dimensional face space model proposed by Valentine, as we experience more faces in our daily life, these faces are stored into our cognitive face space and forms a prototypical average. These exemplars of face increase as we see more faces. With regards to the other race effect, it is hypothesized when a person had less exemplars of other race faces in their face space, these faces are densely clustered in the face space, leading to a deficit in differentiating and recognizing other race faces, as there are many neighboring exemplars interfering with accurate recall of a face. Similarly, because of the other race faces are densely clustered together, it leads to faster categorization of these faces. Besides the perceptual learning models, the social cognitive theories have been proposed to explain the other race effect. The social cognitive theories emphasize that different social categorization of own and other race faces results in different encoding of these faces. Levin, in his feature selection model, proposes that we see race as a visual feature and are experts in categorizing a face as in-group or out-group. This categorization then leads us to encode features in a face differently. He suggested that we process other race faces at a categorical level and own race face at an individual level. That is, a Caucasian person would categorize an individual Chinese face as simply Chinese, resulting in homogenization of the other race faces. In contrast, When processing faces of our own race, we process individual unique traits such as familiarity, personality, attractiveness of that face, and hence are better at remembering and individuating own-race faces. These different encoding systems are then taught to result in recognition bias in the ORE. In categorization individual model, categorization of a face is not only elicited by race, but can be influenced by social or cultural identity. This motivation affects how we categorize the face, either as own or out group, which then affects how we remember the face. While both these models provide new perspective in explaining the other race effect account, it does not sufficiently explain the early emergence of the ORE in infants. Because experience has been said to affect the other race effect, researchers investigated this in infants, and they found that before the age of 6 months old, infants were able to recognize faces of all race, but the ability to distinguish other race faces begin to decline at about 9 months of age. This process is then termed as perceptual narrowing, which suggests that infants begin with a broadly tuned perceptual ability that allows processing faces in general. Then, as they experience more faces of specific type, there is a decline in sensitivity to rarely experienced faces and an increase in sensitivity to frequently experienced faces. We see this process happening in infants' language development as well. Several adoption and training studies have demonstrated that the ORE can be readily reversed given experience with other race faces. For example, adoption studies conducted by Sangrieli and colleagues in 2004 demonstrated that children ORE is reversible. In this study, adult participants of Korean origin who were adopted by European Caucasian families when they were children showed better recognition of Caucasian faces as compared to Asian faces. Evidences from this and other studies suggest that ORE can be reversed with increased exposure with another face race. Another relevant area of face recognition, which is less researched, is how we categorize faces. Contrary to the ORE, when an individual is asked to categorize a face by race, they are faster and sometimes more accurate in categorizing other race faces than in categorizing own race faces. This phenomenon is known as the other race categorization advantage. The ORE effect has received support from behavioral and neuroimaging evidence, especially with adults population. While there are some studies that demonstrate the ORE effect in adult population, however, less is known about the development of ORE in children. To date, there are no data examining the ORE effect in children, and only 2 studies looking at categorizing of faces according to race in infants. Because most studies in ORE and ORA have been done with monoracial population, it is important to investigate this effect with a multiracial society to further explore the influence of consistent exposure to different faces on these processes. Past training studies findings have found to alter the other race effect, but these effects can be transitory and do not demonstrate the effects of permanent immersion in multiracial environment. As live social interaction may provide a rich representation of faces through variety of emotional expression, viewpoint, and social context, it is important to investigate whether live social interaction leads to faster reduction in the other race effect. To extend the literature in this area, the present dissertation aims to investigate the development effect of recognition and categorization phenomena in a multiracial country. Malaysia is a country that represents a unique opportunity to investigate those issues. Malaysia population consists of Malay, Chinese, Indian, and other ethnic groups. A multiracial environment in Malaysia provides a good natural experiment to understand how live interaction with different ethnic groups influence the way the face processing system has developed. In this thesis, the role of experience in the development of face processing, specifically in two areas, recognition and categorizing of faces, will be explored in a heterogeneous population. An overview of current knowledge of face processing will first be discussed before exploring the importance of experiences in the way we categorize and remember faces. In addition, we will also look at whether differential experience affects the way children associate genetic relatedness to cues in faces. To answer these questions, 4 studies were conducted. In the first study, we look at how differential experience affects infants' face recognition. In the second study, we look at this effect in children and adult face recognition. In the third study, we look at the effect of differential experience on children's categorization of faces. And in the last study, we look at the effect of differential experience on preschoolers' detection of kinship relations among strangers' faces. Based on past study evidences, experience plays a crucial role in influencing the face processing system. According to the perceptual learning model, it is hypothesized that experience will influence Malaysian infants, children, and adult perception of faces. Specifically, we expect Malaysian infants who are not exposed to other race caregivers to have the other race effect. Malaysian children who are exposed to other races in their environment to have less ORE and ORA, depending on their other race exposure. Malaysian adults who have extensive exposure to other races will not have an ORE effect for experienced faces. Differential experience with other races may extend to children's ability to detect kinship relations between strangers using skin tones as one of the phenotypical cues in the experiment. In the first study, an investigation of differential experience in infants' face recognition was done. In this study, we extended Tam, Bremner, and Hay 2015 study of British infants to Malaysian infants. Tam and colleagues found an other race effect with 4-month-old Caucasian infants, but this effect was only limited to female faces. By 8 to 9 months old, an other race effect was found across both male and female faces. In this study, we are interested to investigate if infants in Malaysia who may have other race caregiver experiences differ in their face recognition process. There are 2 possible hypotheses for this study. According to the primary caregiver hypothesis, infants should show a recognition advantage for female over male faces, regardless if they are own or other race faces. Alternatively, according to studies showing the importance of infants' extended environment in visual preference and face scanning studies, infants' face recognition might also reflect the racial and ethnic composition of a broad population, such that Malaysian infants will be good at recognizing both Chinese and Malay faces, but not Caucasian white faces. 3 to 4-month-old and 8 to 9-month-old Malaysian Chinese infants were tested in this study. A questionnaire was administered to get information about infants' social and caregiving environment in regards to own and other race interaction, race and gender of other race caregivers. Infants were shown male and female faces from one of the 3 ethnic group conditions, which are Chinese, Malay, or Caucasian faces. Infants were first habituated to a face and then tested with familiar face paired with a novel face. Face recognition is indicated by longer looking at the novel face. In the result, we found a larger novelty preference score for female Chinese faces over male Chinese faces. No difference was found for Malay and Caucasian white faces. This indicates that Malaysian Chinese infants look longer at Chinese female faces, indicating an ORE for female Chinese faces, confirming the primary caregiver hypothesis but only to own race faces. As we also measured information about the infant's caregiving and social environment, we ran some analysis and found that infants in our study to have highest proportion of interaction with Chinese faces, little interaction with Malay faces, and very little to no interaction with Caucasian faces. In general, infants interacted with female faces more than male faces. We also wanted to examine whether direct exposure to other race female faces through additional caregiving roles had an effect on infants' novelty preference for Malay faces. We conducted a further analysis and compared infants with direct exposure to other race female faces with infants without direct exposure. We found a novelty preference in 8 to 9 months old infants with direct exposure to other race female faces was significantly above chance level, whereas those without direct exposure was not significantly above chance. This suggests that the other race female exposure resulting from contact with additional caregivers may have enhanced recognition of female Malay faces by 8 to 9 months old. In conclusion, this study suggests that in a sample of infants raised in multiracial environment, the own race recognition advantage develops first for primary caregiver's gender, with some evidence that this is later extended to an experienced race of the same gender. The study highlights the importance of obtaining social and caregiving information to completely understand the transition nature of the face processing system. The findings are consistent with the primary caregiver hypothesis and the differential experience model of face processing, according to which infants' face processing is continually refined over time and depends on social and visual experiences. This concludes our findings for study 1. In study 2, the effects of differential experience in children and adults' face recognition was investigated. In this study, we were interested to know if children and adults from a multiracial environment manifest the typical ORE for other race faces, as Malaysians also frequently interact with other races. As there are only 2 studies on adult and children face recognition done in Malaysia, there is a need to research and replicate this area further using other behavioral methods and participants to provide a better understanding on how Malaysians recognize faces. In this study, we used the term low-frequency other race to refer to Caucasian faces used in the study, own race to refer to faces of the same race as the participants in the study, and high-frequency other race to refer to other race faces that participants are frequently exposed to. According to the contact hypothesis, the ORE should decrease as exposure increases. We expect recognition accuracy to be lowest for other race faces that are less frequently experienced and higher for own race and other race faces that are frequently experienced. 2 separate studies were conducted in study 2, one for adults using the old new paradigm and another for children using the forced choice paradigm. In the adult study, we tested 27 Malay and 27 Chinese from the city of Kuala Lumpur, which had a higher proportion of Chinese population. Based on this demographic and contact hypothesis, we hypothesized that Malay and Chinese would have similar recognition performance for Malay and Chinese faces, and poorer recognition performance for other race Caucasian faces. All participants were asked to learn a series of faces and was then asked to recognize the face they had seen before. Participants went through the learning and recognition phase for all 3 race conditions, which are Malay, Chinese, and European face. To ensure that participants' face recognition is based on the face identity information and not view-dependent matching of images, pose of the stimulus phase were altered across learning and recognition trials. If participants view a face in frontal orientation during the learning phase, they will see a profile orientation of that learned face during recognition. Here is the percentage accuracy results of the adult study. Malaysian adults, regardless of which race they were significantly more accurate in recognizing Malay faces compared to low-frequency other race Caucasian faces, indicating a typical ORE effect. However, participants had similar recognition performance for Malay and Chinese faces, which does not conform to the typical ORE effect. No significant difference were found for the reaction time results. In the adult study, we found the lowest recognition accuracy for the low-frequency other race Caucasian face, indicating a typical ORE effect. As predicted, there was no ORE effect for high-frequency other race faces, as both Malay and Chinese participants responded to this class of faces like their own race face. This is not surprising given that adults in Kuala Lumpur have had extensive experience with both Malay and Chinese faces. This finding is consistent with the version of the contact hypothesis in which other race faces need to surpass some threshold of experience in order to be responded to as own race faces. I will now present the children study. In the dissertation project, 3 children study was conducted, but due to time constraint, I will only be presenting one of the children study here. 7, 10, and 13-year-old Malay and Chinese children were tested individually using the forced choice paradigm. Children were given a face to remember and then were asked to identify which was the face they saw during the test trial. The face orientation that children saw differed from familiarization and test face. If participants saw a frontal face during familiarization, they will see a profile face during test trials and vice versa. All children saw Malay and Chinese faces in separate blocks. In the result, we found that Malay children had equal accuracy performance for Malay and Chinese face, indicating an absence of ORE. But Chinese children had better recognition performance for Chinese faces compared to Malay face, showing an ORE for Chinese children. 2 possible reasons could account for our results. 1, Malaysian Chinese children were tested mainly from Chinese vernacular school, which consists of mainly Chinese students and teachers. And secondly, children were tested in an area with significantly more Chinese population compared to other parts of the country. Hence, Malay children may have more exposure to Chinese population. Given this increased exposure, it is not surprising that Malay children is able to recognize both Chinese faces and Malay faces equally well. In summary, the development of the ORE is unclear during childhood. While it appears that certain exposure to other race faces affects the ORE, the relationship between exposure and face recognition is inconsistent within the Malaysian children tested. One limitation with our study is that we did not directly measure participants' exposure to other race faces. Hence, we are unsure if children experience the same amount of other race exposure. More testing needs to be carried out to understand the mechanism behind the ORE development in Malaysian children. Overall, we see that exposure to other race faces affect how we recognize faces in a multiracial society. In infants who do not have much exposure to other race faces, a typical ORE effect is seen. However, this own race recognition advantage for own race female faces is later extended to an experienced race of the same gender if the infant have exposure to other race caregiver. In adults with increasing exposure to multi-races over the years, Malaysian adults develop an equal ability to recognize own and frequently exposed other race faces. This recognition advantage begins to change in childhood. In study 3, we investigated the effect of differential experience on children's categorization of faces. Based on previous study, experience with other race faces moderate the other race effect. In this study, we would like to investigate if the other race categorization advantage is also modifiable with ample exposure to other race faces. Social categorization models have also been used to explain own race recognition and other race categorization advantages. When encountering a face, we rapidly categorize it as belonging to our in-group or an out-group. A hypothesis based on social categorization implies that the other race categorization advantage results from the race of a face, determining the way we categorize faces, with the race of a face and its similarities to the categorizer being determined by its skin tones, physiognomic features, or some combination of the two. The perceptual expertise hypothesis instead predicts that the other race categorization advantage depends on the frequency of exposure to faces in the multiracial environment. According to this hypothesis, the other race categorization advantage should decrease as exposure increases, meaning the ORA should be largest for racial groups with the least exposure to other race faces. In the categorization study, Malay and Chinese 6-year-old children, 9-year-old children, and adults were tested. Similar to the other race effect study, we presented participants with a low-frequency other race face, a high-frequency other race face, and an own race face. All participants saw a Caucasian, a Malay, and a Chinese face. The categorization task was administered in 3 blocks. In each block, participants were asked to categorize 2 race faces, either a Malay versus Caucasian face, Malay versus Chinese face, or Chinese versus Caucasian face. Each face was presented one at a time, and participants were instructed to respond as quickly and accurately as possible by pressing one of the 2 keys on the computer to indicate which race they had seen. Here's the result of the study. The top half of the graph reflects the accuracy results, and the bottom half of the graph reflects the response time result. When we look at the accuracy result, generally the Caucasian faces having low frequency in Kuala Lumpur were categorized more accurately than the more frequent Chinese and Malay faces. Adults were more accurate for both Caucasian and Chinese faces relative to Malay faces. In contrast, 9 to 10-year-old children were more accurate for Caucasian faces than for both Chinese and Malay faces. The younger children were more accurate for the Caucasian faces than for both the Chinese and Malay faces. The difference between Chinese and Malay faces was not significant. When we look at the response time result, for the 6 to 7-year-old, both Caucasian and Malay faces led to longer response times than Chinese faces. In contrast, in the 9 to 10-year-olds, the effect of face race was best described by a linear increase in response time. Caucasian faces led to shorter RT than the more frequent Chinese faces, and Chinese faces led to shorter RT than Malay faces, which are the most frequent in Kuala Lumpur population. The same trend was found in adults. In the categorization study, the response time data are entirely consistent with the perceptual expertise hypothesis. Both Malay and Chinese 9-year-old children and adults responded fastest to Caucasian faces, followed by Chinese and then Malay faces, with the exception of the younger children. One possibility for this could be the younger children took longer to look at the Caucasian faces due to curiosity of these group of unfamiliar faces. Chinese children and adults responded more rapidly to Chinese and Malay faces. This study indicates that the other race categorization advantage is modifiable with other race exposure, and the ORA is an advantage for racial categories of lesser experience. Based on study 1, 2, and 3, we know that experience with other race have an impact on our face processing ability. We would also like to know if this experience may also affect the way we detect kinship resemblance. In study 4, the effects of differential experience on preschoolers' detection of kinship relations among stranger face was investigated. We know that facial recognition system is in place early in life. Some studies have shown that children understand that race is immutable. In this study, we are interested to know if greater experience with faces of different races predicts an increase in children's understanding that skin color is inherited. Preschoolers from France representing monoracial environment and preschoolers from Malaysia representing multiracial environment were tested on a facial kinship detection task. Each children were tested individually using a computer. Participants were shown a mom and a dad from the same or different race and were asked to determine which child at the bottom of the picture is likely to be their child. The choice of children comparison stimuli was between a child of African, Caucasian, Chinese, or mixed race. Each face race of parent and child was only seen once by participants to avoid learning effect. If the mom and dad are of the same race, we expect that the correct kin matching to be the same race. We refer to these items as intra-racial items. If the mom and dad are of different race, we expect the correct kin matching to be of mixed race. We refer to these items as interracial items. To explore kinship detection ability, we calculate the total number of items that each participant had answered correctly. The results were surprising, as Malaysian children, despite having more exposure to other race faces, did not perform better in kin matching tasks. Instead, it was the French children who performed better. When we compare Malaysian children who were from the same race parents versus children who were of mixed race children had higher performance in total kin matching tasks. Further analysis was conducted to check if kinship detection ability was reliable in preschool children. We found that all children had above chance level for all items, except the interracial items, indicating that both groups of children had difficulty with these items. Overall, our hypothesis that Malaysian children may have an advantage in the kinship matching task was not supported. There could be several reasons for this. While Malaysians in general may be exposed to multiracial population, we are unsure the extent of multiracial and mixed race exposure for Malaysian preschoolers. In addition, Malaysian children are unfamiliar with Caucasian or African faces used in the experiment. Another alternative explanation to consider is about the effect of second language learning on biological inheritance understanding. In a study by Byers, Heinlein, and Garcia in 2015, comparing monolingual, simultaneous, and sequential bilinguals on their belief about innateness of physical and behavioral traits of humans and animals, they found that second language learning reduces children's essentialist bias. Children who are sequential bilinguals tend to believe that human and animal traits are acquired through the environment rather than innate. As it is common for Malaysian preschoolers to start learning a second or third language, this may have influenced their judgment about kinship matching in this task. In this PhD, the thesis attempts to investigate three questions. How does differential experience in a multiracial environment affect facial recognition in infants, children, and adults? How does differential experience in a multiracial environment affect face categorization in children and adults? How does differential experience from a multiracial environment affect preschoolers' ability to detect kinship relations? For the first question, multiple evidences were found in this thesis that support differential perceptual experience affecting the other race effect in infants, children, and adults born and living in a multiracial population such as Malaysia. Overall, the experiments demonstrate that the development of ORE in a multiracial environment is complex and then dependent on experience with different classes of faces. Exposures to different classes of faces may change from infancy to childhood and only become stable in adulthood. The study highlights the importance that face recognition performance seems to be more advantaged for racial categories of higher experience, regardless of whether these face categories are own race or other race. For the second question, our study found that differential experience modulates the way we categorize faces. In accord with a perceptual expertise account, the other race categorization advantage seems to be more an advantage for racial categories of lesser experience, regardless of whether these face categories are own race or other race. Lastly, how does differential experience from a multiracial environment affect preschoolers' ability to detect kinship relations? Being raised in a multiracial environment did not give an advantage in detection of kinship performance. Instead, preschoolers from mixed race families were better in kinship matching task performance. The results suggest that direct experience with mixed race families increased preschoolers' understanding of biological inheritance. Future work involving older children are needed to further understand the development of this ability. A limitation of our study is that we did not measure interracial experience directly. Amount of contact with other race faces has been found in some studies to moderate different aspects of responding to face race. Future work using contact measures may provide further information about the individual variation with other race contact and how it influences the development of the other race categorization advantage. In addition, eye tracking studies can be carried out to investigate how faces are scanned in this population. Based on Valentine face space model, we see that the own and other race faces may be encoded differently in the face space. We also know perceptual narrowing happens for language and faces in infants at approximately the same time. Using Valentine's model, perhaps language encoding for native and non-native speeches are also encoded similarly in the language space. As Malaysians are also exposed to different languages and we use face to communicate, it would be interesting to investigate how language may influence the face processing system. Before I end, I would like to express my gratitude to my main supervisor, Dr. Olivier Pascalis, and co-supervisor, Dr. Karine Mazens, who have helped me tremendously in my PhD journey. I would also like to extend my thanks to all the participants who have participated in my studies and all the schools who have given me permission to test the children at the school. Thank you. That's the end of my presentation.